Hey, algebra class, guess what? This is our last unit. Alright, so what we're going to be doing for today is we are going to start in on these things called systems. So all a system is in math is it's a set of equations combined by and when instead of saying like and, we use this little symbol here, like the little squiggly brace. And what we're really trying to do is we're trying to find something that solves them both at the same time, right? So that's what the solution to a system is, right? It's an ordered pair, right? It's got an x and a y that makes a sentence true, right? So, when we're talking about a system kind of like this one, oops, thought I had the highlighter on, just like that one down there, right? We can kind of think of that as a sentence, right? It's saying y is equal to 3x minus 7 and 2y minus 2x equals 10, right? So one of the ways that we can, find some solutions is we can go ahead and we can actually just plug in some points. So that's what we're going to focus on today. I will say that plugging in points is not the most efficient way to find the solution to a system, but it is an awesome way to be able to check your work when you use some of the methods we're going to learn later over the next couple weeks. So the first thing we're going to do is we're going to try and check these 2 points, right? So one of them I'm going to do is 611. So what I'm going to do is I'm going to do all of the work for 611 in red, and then I'll switch over and I'll do 1, -4 in blue, right? So for 611, right, that point has an x and a y, right? So all I'm going to do is I'm going to take these 2 equations that I have, and I'm going to plug in those numbers for x and y, see if they work. So for y equals 3x minus 7, right, that first equation there, the y is going to turn into 11, just like it is up in the point up there that I'm checking for. I'm then going to keep on going, and then I'm putting in 6 where there was an x. So when you're writing this out, right, when you're doing this on your own, don't just write in, oh, now it's 36, right? 3x is 3 times x, so this is actually 3 times 6. So we can put it in parentheses to make it a little bit easier to see that. Right? All we have to do after that is we're really just going through and simplifying this, right? 11 is still 11. 3 times 6 is 18. And then we can simplify that side a little bit more. 18 minus 7 is 11, right? So that looks like it works to me, right? So we know that 611 works for just that first equation. So the thing is that just like this definition up top for a system, we're trying to solve them both at the same time. So what I need to do is I still need to check and see, does 611 work for this second equation here? All right, so give myself a little bit of a divider here. For this second one, we've got 2y, so 2 times the y, which was 11, minus 2 times the x, which was 6, equals 10. And so what we're going to do is same kind of deal. I'm just going to run through this, I'm going to simplify it down and see if it comes out right. So 2 times 11 is 22, 2 times 6 is 12, 22 minus 12 is indeed 10. All right, so that works. So what that's telling me is that 611 is a solution. Right? It solves both of those equations in our system at the same time. Right? We didn't change what the x or the y were. Right? We plugged in 6 and 11 both times. Right? So that's what makes that a solution, is if it solves both of them at the same time. I'm just going to squish that down a little bit so we have some room to try out this other one, 1, -4. All right, so same kind of deal. It's got an x and it's got a y. I'm going to start off with just the first equation. Right? So give myself another divider to separate it that way a little bit. So I'm taking this first equation, y equals 3x minus 7. All right, so y equals 3x minus 7. What I'm going to do is I'm going to plug in a -4, because that's the y that I'm working on with this one. And then over on the other side, it's 3 times 1 minus 7. Right? Same deal. I'm just going to simplify. 3 times 1 is 3. 3 minus 7 is -4. Right? So that works. Right? So that first equation is solved by plugging in 1, -4. We still need to make sure, right? Don't forget to do this when you're doing these on your own. You need to make it work for both of them. So I'm going to double check. I'm going to do 2y minus 2x equals 10. All right? So 2 times the y, which was -4, minus 2 times the x, which was 1, might give me 10. All right, let's check it out. 2 times negative 4 up front is negative 8. 2 times 1 is 2. Negative 8 minus 2 more is negative 10. Oh dear, I don't know about you guys, but last I checked, negative 10 was not the same thing as 10. Right, so this one does not work. Right, so what we would be able to say here is that 1, negative 4 is not a solution. Right, it's all fine and dandy that it worked over here for this first one, but if it doesn't work for both, it's not a solution to the system. Right, so that red point, 611, worked out. It worked for both. Blue one did not work for both. Okay. What we're going to do is we're going to try another couple examples out, plugging points in and seeing if they work. And so for this one, we've got a couple of different points, and I've spaced them out a little bit more appropriately down here. So our system is way over on the left there, right? It's y equals 4x minus 11 and 5x plus 2y equals 4. All right, so I'm going to start off with this first point here, 4, 5. It's got an x and it's got a y. Something that I still do, like years and years after learning this for the first time, is that I still label them as x and y, just so I don't end up messing it up later when I'm plugging things in. So I'm going to take y equals 4x minus 11. I'm going to replace the y with the 5. I'm going to replace the x with 4. And we're just going to see what happens. Right? 5 equals 16 minus 11. And 16 minus 11 is 5. Right? Looking good so far for this point. I still got to check it in the other equation, which is 5x plus 2y equals 4. All right, so again, I'm replacing the x with 4. I'm replacing the y with 5. And then we're just simplifying this down. All right, 5 times 4 is 20. 20 plus 10. Oh dear, 30 is not equal to 4. Don't go home and tell everybody like, oh my god, Mr. Pog said 30 is equal to 4, because it's not. Right? So this one is not a solution. Right? Because it worked for one of them, but that doesn't mean anything if it doesn't work for both of them. Right? So let's try out 2, negative 3. Right? Same kind of deal. Right? It's got an x, oops, not in blue highlighter, just in blue pen. It's got an x and a y. All right, so first equation, y equals 4x minus 11. Right? Well, the y is negative 3, the x is 2. So again, I'm just going ahead and plugging those in. Be real careful as to which one you're plugging in where, right? This one has the y come first, and then the x is a little bit later in the equation, right? I don't know if you noticed that, but when I'm plugging it into the second equation, the x comes first, and then it's the y a little bit later on. So be careful to know that you're plugging the right number in the right spot. Right, so we keep on going with this one. The negative 3 is equal to 8 minus 11. Sure is, because 8 minus 11 is negative 3. So that works out. Still need to go ahead and check out my other one. We've got 5x plus 2y equals 4. Alright, so 5x is now 5 times 2 plus 2y, so y is negative 3. And we'll see what that comes out as. 5 times 2 is 10. 2 times negative 3 is negative 6. And how do you do? 10 minus 6 is 4, so 4 equals 4. Right, so 2, negative 3 rather, is a solution. Right. And that's really all we're doing today, right, is we're just checking out these points, seeing if they work out or if they don't. Right. Ugh, these ones look a little nasty, right, but let's talk them through. Right, so on this one we've got 8x plus 4y equals 16 and y equals negative 2x plus 4. Right, so let's try out this first point here. Right, we've got an x and a y. Right, I'm going to kind of skip over the step where I've been like, oh, writing out x plus 4y. Right, I'm just going to plug them straight in. Right, so this is 8 times the x, which was 1, plus 4 times the y, which was 2, equals 16. Well, that's 8 plus 8 equals 16. And 16 all around. That one works out. Right. If I'm checking out that second equation, y equals negative 2x plus 4. That's y, which was 2, equals negative 2 times 1 for the x, plus 4. Negative 2 times 1 is negative 2. And negative 2 plus 4 equals 2. All right, so this one also works out. So 1, 2 is a solution. All right, cool. And so if it keeps with the theme that's kind of seemed to crop up here and there, right, this next one might not be a solution. Let's check it out. All right, so same kind of deal. We'll label these as x and y. And this is where it gets really, like, I guess what I'm trying to say is be careful when you're plugging these in, right? Because if one is 4 and one is negative 4, it is really going to matter which one you plug in where. And it's pretty easy to mix them up if one's a positive and one's the negative of the same number. All right, so on that first one, it's 8 times the x. The x was positive 4. Plus 4 times the y, which was negative 4. All right, and then equals 16. And you can see that these parentheses are pretty important, right? Because this is not 84 plus 4 minus 4, right? That's all multiplication going on there. And so 8 times 4 is 32. 4 times negative 4 is actually negative 16. So we're going to replace that with a minus 16. 32 minus 16 is 16. Cool, works out. Let's try it out for the last little bit we got here. All right, so this is y, which was negative 4, equals negative 2 times the x, which was positive 4, and then plus 4. This is negative 4 equals negative 8 plus 4. So we'll have negative 4 all around. Right? So that means that 4, negative 4 is also a solution. Right? So this one's actually pretty significant that we could find 2 different points that were a solution to this. Right? So the next lesson that we're going to be doing is taking a look at another way that we can solve these out where we're not just plugging in points. Right? We're actually going to take a look at the graphs of these. Right? And this one is actually pretty significant. We're going to use this exact same example, right, in that one. And we'll kind of talk a little bit more about why, like, oh wow, it has 2 solutions, right? Why that's important. Right? But for now, all we're worried about is that we plugged it in. It ended up working out both times. Pretty sweet. And it wouldn't be math class if it didn't get a tiny bit worse. Right, we're going to take a look at a little bit with fractions, right, just to kind of talk through how to handle them. It's not going to be that bad. Right, so try this out. Right, I've got an x and a y, I've got a negative 4 and a positive 4. Right, so same kind of deal as on the last one. Be real careful when you're plugging these in. Make sure you have your x in the right spot and your y in the right spot. All right, so on that first equation, y equals negative 1/4 x plus 3. Right. Well, the y is 4. The x is negative 4. All right, it's a little bit squished in there. I'm going to kind of rewrite that second half. So 4 is equal to negative 1/4 times negative 4 plus 3. All right. So when we're doing all this distance learning stuff, right, obviously you can use a calculator on anything you want, right? That's true even if we were in class. Right, but let's talk about how to do negative 1/4 times negative 4. Right, so negative 1/4 times negative 4 is really what we're doing in this little chunk right there. So the way that we can multiply when there's a fraction involved is we could treat this negative 4, well, how do you do? It's the same thing as negative 4 divided by 1. Right? When we've got 2 fractions that we're multiplying, you multiply the tops together. So negative 1 times negative 4 is positive 4. 4 times 1 on the bottom, when you multiply the bottoms together, gives you 4. And 4 divided by 4 is the same thing as 1. Right? So it's really not so bad, right? You just take it one step at a time. Right? So what we're going to get out of that multiplication with the fraction is just 1. So this is now 1 plus 3. And last I checked, 1 plus 3 is 4. Cool. Works out there. Right. Next part, right, we're doing y equals negative 3 halves x minus 2. Right, so let's check it out. Y was 4 equals negative 3 halves, and then x was negative 4, and then minus 2. All right, so this fraction already looks a little bit nastier to multiply with, but we're going to do the same thing we did last time. All right, we have negative 3 over 2 times negative 4, and I'm going to put it over 1 just like we did last time. what I'm going to do is I'm going to multiply the tops of the fractions together and the bottoms together. So negative 3 times negative 4 up top is going to give me positive 12. On the bottom, 2 times 1 gives me 2. And 12 divided by 2 is the same thing as 6. Right, so all I'm going to get out of that is I'm just going to turn all that big chunk into 6. And I'll tack on that minus 2. And so the fractions, look scary, but they're really, like, it's like when they say his bark is worse than his bite, right? Like, they look awful, right? But then when you go through them and you kind of know what you're doing, they're not so bad. Right? To finish this one off, 6 minus 2 is 4. This works out. Okay, so that turns out that this is a solution for negative 4, comma 4. Last little chunk here, right? We've got 0, negative 2, right? So the nice thing about this one is that it's got a 0 for the x. So let me show you why I'm excited about that one. So we got y equals negative 1/4 times x plus 3. Well, anything times 0 is just 0. So over on that side, that turns into 0 plus 3. Negative 2 is equal to 3? Question mark? I don't think so, buddy. Negative 2 is not the same thing as 3. Right? So theoretically, we could stop here. Right? We know that this is not going to be a solution. Right? And honestly, we're perfectly fine doing that. Right? If it doesn't work for both, I know it's not a solution. So there's not really much of a point in finishing this one out. If you really wanted to, I can do it out real quick if you're curious about what it'll look like. Right, it's y equals, oops, the y was negative 2, going a little too fast. Negative 3 halves x minus 2. This is 0 minus 2, and negative 2 does equal negative 2. Right, but again, it doesn't work for both of these. Right? So the fact that this one did not work out, the fact that this does not work for that first equation, means that that is not a solution for that one. Right, so overall, we have to say that this is not a solution. Okay? And that is it for this one. Be sure to check on Google Classroom for any additional stuff, and be sure to reach out to your teacher if you have trouble with these. Right, we're here to help you. See you next time.